I'm Surrendabite. I thought today that I'd show you, do a more in-depth video on my twisted conveyance module, point out some problems and that sort of thing. You may have seen my other video, but I was just showing you the module like most people do, you know. But today I wanted to talk about it a bit more. As you can see, it's in a small loop with another one of my newest modules. It's already coming pretty handy, but that's not what the video is about. So I guess I'll start out with this part, which actually turned out to be the hardest part of the entire design. If I hadn't had to deal with that, it would have been done in a few days. So I tried numerous mechanisms to keep that stationary. Well, actually, before that story was kind of another story. So I was trying to figure out a mechanism to load it on to the actual twisting conveyor thingy, and tried pistons, I tried this, but then I realized it extended one step farther every time it twisted half a twist. See, one time, another time. Well, on one of those it would stick out farther, which was disrupting the whatever little thing I have there. And then I realized that the conveyor has an even number of holes. It would have to be an odd number to make each side equal, but it's an even number, so it stuck out farther. So I had to make this mechanism to do it halfway. And then I have a giant problem of this, which was possibly a bigger problem than the other problem. And, well, I don't really know what to say. It took a long time to figure out this. You might be wondering, why did it take a long time to figure out this little mechanism? Well, this has to stay stationary, because each full rotation of these sprockets, for lack of a better word, I guess, every time these turn a full rotation, it moves 10 track links. Yeah, conveyor links. So there's 30 links on here. So every time it rotates half, every half rotation, it moves 10 links. So in a rotation and a half, it dumps the ball when it originally picked up here. So the gear ratio is 5 to 1 to 1 to 5, so the overall ratio is 1 to 1. And yeah, so you can see it's kind of crooked if you watch carefully. It moves from side to side because it's on. I didn't do the half mechanism, even though I'd love to, because it would have made things so much simpler. I wasn't able to do that. So I tried a whole bunch of different mechanisms, like having a 8-tooth gear right here, and another 40-tooth gear here. So they will rotate, and it'll rotate here, and it's kind of hard to explain without actually seeing it, and I'm not going through all that again. So it would stay stationary. But then that didn't work, so I tried universal joints. That kind of worked, but the mechanism kind of twisted itself, and there was a heck of a lot of friction, and it couldn't move. So eventually I got fed up and just tried this, and it worked. But it would kind of tilt from side to side, so I had to make a big wall and put these pieces on it to keep it in the same position. Yeah, geez, 4 minutes for one thing. Alright, here's the input. I very recently, just before this video in fact, adjusted it so that there was kind of a lot of friction here, and I had a ratio of 2 to 1 here, and we're just 2 sets of these. Then I realized, why do that? I had to have a little thing and it kept popping off. Sorry, I'm not really explaining this well. So anyway, I just added another 2 here, another 2 sets of these, and now it's the same ratio every time. and I had to make this very carefully. So there's 20 tracks. There's 20 track lengths to be able to time it the same as this. Because I had a problem with my Geneva drive, where the input was slightly faster than the actual drive. So balls would kind of pile up, and that created a big problem. When Geneva drive has a lot of those. Yeah, so this has to be in the exactly right place. Too low down, it won't pick it up. Too high up, this will catch and do weird, not desired things. This was this was from my square scooper for a long time ago, sort of, and RIP square scooper. I just used a conveyor for the end of this. Wanted to keep it simple. All mechanisms are conveyors. And so yeah, I managed to run it all by one motor, which is kind of my goal nowadays. Here, I showed this part in my other video, but I decided why not. So yeah, universal joints are extremely handy, so a big thanks to whoever invented those. And these things, I tried to find them on eBay, and I searched like 100 different results, and then eventually I found one where a title had like 5 different words to describe it. Like smooth T joint thing, I don't remember what it was. So yeah, oh wait, it was a U. Yeah. I built it Akiyuki style with the beams and these pieces. It's extremely sturdy, I can pick it up. Although I'm going to have to reinforce this if I want to do that without pressing it down every time after I do it. I can, well, not exactly an upgrade. I can turn it by a crank. So that's kind of fun. Even though it's not very practical. Whatever, I'll deal with that later. So, that's kind of it. Thanks for watching. Please subscribe if it benefits you. And see you next time.